Hey, what do you say there, Math Leaguers? I am back for part 2 of the wrap-up for week 2 of the 2025 Math Whiz League Session 1. It gets to be a lot, doesn't it? So I did the first 9 problems. I just thought I'd break the video into like 2 smaller videos. And I also wanted to bring Tristan, the math wonder dog, in for doing the last problems, 10 through 15. What? You say you don't want to do it? You say the problems are too rough. He says the problems are too rough. Okay, I think I've already told that joke before, but it never gets old. It really doesn't, okay? So, I don't know, I guess we can embark upon this journey without you. Maybe you could come back at the tail end of it? Oh my gosh, these puns are terrible. I'm gonna let you go. All right, there you go. And here we go. This is problem number 10. Problem number 10 said that there was a basketball that was selling at some store, and they took 20% off, then they took another 25% off, and then the final price was $48. What was the original price? Now, what I like to do when I get a problem like this, I like to pretend that I knew what the original price was and that it was $100. I like to work with 100 because it's the easiest thing to work with when working on percentages. Bear with me for a second. So what I said, let's pretend the basketball was $100. It says we took 20% off. That's easy. 20% of 100 is 20. So the price is now 80. Then it says we took an additional 25% off of that. 25% of 80 is still really easy, right? That's a fourth of 80, which is 20. So we took another $20 off, okay? And now we're at 60. Now, we didn't get to the final price of 48. So our original price was not $100, but check this out. 60 is 60% of 100. So the final price is 60% of the original price. So we could say that if our final price was X, 60% of X, or like 60 hundredths of X, is 48. And I'm going to be right back. I'm just going to go let my dog out of this basement. And don't go anywhere. Come right back. Okay? I'm back. All right. Anyway, so 60% of what we started with is 48. We can divide both sides by 0.6. And the original price was $80. Okay? All right. Question number 11. 3 to the 103rd power. What's the ones digit, the units digit? Okay? Well, if you type it into a calculator, you're going to get a long number, but it's going to be in scientific notation. It won't just fit on your calculator. Don't Google it or AI it or whatever, okay? It'll tell you, but that's no fun. All right, so find the power. 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. 3 to the fourth power is 81. 3 to the fifth power, 243, so my units digit is 3. Sixth power, the second group, the units digit is 9 again. The third one in this second group is the units digit is 7 again. And the fourth one, the units digit is 1 again. I did the math, right? So, every fourth power, the units digit is 1. So 3 to the 100th, 3 to the 100th, will have a units digit of 1 at the end, okay? 3 to the 101st is kind of like 3 to the first. That'll have a units digit of 3, 101st. 102nd is going to have a units digit of 9, and the 103rd is going to have a units digit of 7. It's going to be a gigantic number, but the last number is going to be 7, okay? Cool, all right. And I did that thing where I preloaded a couple of problems onto the whiteboard. So 12 and 13 are already on here. Okay. I just thought this was a really cool thing. I like these. Just something to know. It's converting a repeating decimal into a fraction, lowest terms fraction. So what you do, I don't know if you guys know this, it's one of the things that you guys should memorize. Like 1/9 is 0.1 repeating. 2/9 is 0.2 repeating, okay? Also, I don't know, 47/99 is 0.47474747, and so on like that, okay? Same with 9/99, and so on. When you divide by 9 or by 99, you get a repeating decimal, okay? But this one's a little bit weird. If the line was all over the whole thing, it would be 212 over 999, but it's not. It's only over this. So what it is, right here I have 2/10, but I also have 12/99 of the way to another tenth. So 12/99 of times 1/10, which is 12/990. I get a common denominator, I multiply top and bottom by 99. I get 198 over 990 plus 12 over 990 is 210 over 990. I can reduce that. That's 21 over 99. A couple of you stopped there. You didn't realize 3 goes into both. 3 goes into 21 7 times, and 3 goes into 99 33 times. So the correct answer was 7 over 33. Okay. The next one, 13, it says Isaac had some pieces of candy. He gave 1/4 of his candy to Olivia. Then he gave 3 pieces of candy to Thomas, and he still had 5/8 of his candy left. How much did he start with? So this time like a lot of times I'm giving you guys tricks. This time I'm going to actually use a formula, right? We're going to say the amount of candy Isaac started with is X. So all 1 times X, his whole candy, minus the 1/4 of it that he gave away, minus 1/4 of what he had, minus not a percentage or a fraction, but it said he just gave away 3 pieces. So 1x minus 1/4 of x minus 3 is equal to 5/8 of x, 5/8 of what he started with. Now I like to do this little thing. Some teachers don't like it. I call it flinging. I can take terms and move them from one side of the equation to the other. So I rewrote 1/4 x as 2/8 x. I took the 5/8 x and brought it to the left side and made it minus 5/8 x. I took the minus 3 and brought it to the right side and made it positive 3 or plus 3. Okay? 1x is 8/8, right? So 8/8 x minus 2/8 x minus 5/8 x is 1/8 x, right? Because that's 7/8. 8/8 minus 7/8 is 1/8. So 1/8 x equals 3. 1/8 of something is 3. 1/8 of what is 3? 1/8 of 24. Okay? Cool? All right. Then 2 more problems. Number 14 and 15. Number 14 really is just kind of again, I hope you didn't just like Google it or AI it. It's just kind of a grinded out thing. How many positive integers less than 100 are both a perfect square and a perfect cube? You just got to be careful. So let's list our perfect squares. 1, 4, 9, 16, etc., etc., etc. Okay? And our perfect cube, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729. Okay, and it says it has to be less than 1,000. 10 cubed is 1,000, but it says it has to be less than 1,000. So we're just looking for matches in the list of squares and cubes, okay? And obviously 1 is a match, all right? 16, 25, 36, 6 squared, 49, 64. 64 is a match, okay? Now it gets a little tricky. Okay, what do we got? 9 squared is 81, 10 squared is 100, 11 squared is 121, 144, we're not getting there. All right, 169, 196, and so forth. All you have to really do is see if any of these other ones are squares. 125 is not a square. Okay, 12 squared is 144, 11 squared is 121. 216 is not a square, like 14 squared is 196, 15 squared is 225, no. 343 is not a perfect square. Okay, like 18 squared is 324 and 19 squared is 361. 512 squared is not a perfect square. 24 squared is 484, 25 squared is 625. So, is this a perfect square? Yes, it is. It is 27 squared. So that's our third one. 164 and 729. There were 3 of them. 3 numbers that are both. And then finally, number 15, I'm going to use the formula that's on the sheet that I sent you. Okay? You get these in like math competitions. There is a 5x2 grid. How many rectangles can you make out of this 5x2 grid? This is number 15. Now, again, please don't AI it. All right, so we could count. You could go crazy. You could start like, these are all the 1 by 1s, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. This is like 2 by 1, right? How many 2 by 1s, okay? And that's 1, 2, 3, 4, 5. 5, all right? But you could also do 1 by 2s, right? So it'd be 1, 2, 3, 4, 5, 6, 7, 8, right? 1 by 2s is 8. It would take a long time. Do your 3 by 1s, or not your 3 by 1s, but your 1 by 3s, your 2 by 2s, your 2 by 3s. It's gonna take a long time to add them all up. So there is a special formula when it's like A by B grid, sorry, it's A plus 1 combination 2 times B plus 1 combinations of 2. What does that mean? A and B, it was a 5 by 2, so the A and B are 5 and 2. So this is a 6 combinations of 2 times a 3 combinations of 2. Right, now I don't know if you remember this, what this is 6 times 5, because there's like, when you're doing combinations, like how many combinations of 2 can you make when you have 6? Well, there's 6 choices for the first slot, 5 choices for the next slot. There's 30, but then remembering we have to get rid of the doubles, so we have to divide by 2 factorial, which is 2 times 1. So it's 15, okay, and where's my answer for this one? Did I even put in the answer? Oh, well, that's okay. And then this one is 3 times 2, which is 6, divided by 2, which is 3. So it's 15 times 3. So it was 45. All right, good stuff. Have a good day and have a great week 3. And don't forget, we got a Kahoot coming up. Check those messages. All right.